So this presentation goes over our heat exchanger unit and how it works experimentally. This was done by Natalie Barkley, Matthew Drabant, and Alexander Schlarp. Our advisor for this project was Dr. Feng Qian.
Need and problem for this project is to create a working heat exchanger and accompanying lab procedures. MET 331W, which is the heat transfer class here at Barron, is taught by Dr. Liang Sun, and it needs an affordable heat exchanger as commercial products exceed the budget. The criteria for this project was to minimize size and weight, heat gain from the sink tap, and also minimize input temperature. Some constraints were the cost of the entire project had to be less than $2,000. It had to be mobile and have the ability to be pushed around, which meant it had to be less than 150 pounds. It had to fit through the doorway of the laboratory, which means it had to be less than 6 feet wide. It had to be able to connect to the laboratory sink, and also for the students to measure input and output temperatures, as well as volumetric flow rate. They also had to be able to calculate the wattage used by the electric heater wire, and also had to have the ability to be plugged into a standard outlet, which meant it had to be less than 1500 watts.
This slide, you can see our final heat exchanger design. On the right side of the screen, you can see the fully assembled model, and on the left side of the screen, you can see the disassembled model. On the disassembled model, it is clearly shown the copper tubing in a copper color, where the heating element will be wrapped around. Below that, you can see the red PEX tubing, where there are two routes, one for volumetric flow rate through the middle shelf, where there is a measured beaker. And then on the lower shelf, there's a route to constantly flow the fluid, the water in this case, into a reservoir tank. Advantages to this final design are that the heat exchangers theories that are discussed in MET 331 can be physically observed by the students in the class and then in the lab. There are multiple points of data collection through the thermocouples and the volumetric flow rates. This is a new hands-on lab for the heat transfer class run by our sponsor and customer, Dr. Sun. The wattage of the heating element can be determined through calculations that are taught in the heat transfer class. And the final advantage to this design is that it uses the laboratory resources to allow for easy setup and cleanup.
This slide shows a picture of the overall setup of the heat exchanger. The heat exchanger is located on the black cart, and the heating tape is plugged into the neon green extension cord, which is then plugged into the tower, and that tower is plugged into the outlet in the lab. And the water flows to the green garden hose, which is connected to the laboratory sink. Next slide shows the flow of water through the heat exchanger. It will exit the sink, travel towards the heat exchanger, travel through the copper tubing, the heating tape, and the insulation, and then can either be routed into the volumetric flow rate beaker or into the reservoir.
This shows a close-up view of the top shelf of the cart, where you can see where the water enters through the inlet with the pressure gauges into the orifice and through the copper tubing, which is wrapped with a heating tape and covered in insulation. There are two thermocouples, one at the inlet and one with the outlet, and a third thermocouple inside of the insulation within the heating tape to measure the temperatures of the inlet water, outlet water, and the surface temperature of the tape. From the top shelf, we move into the middle shelf where the water exits the copper tubing into the PEX tubing, where it can either go down into the reservoir at the bottom shelf, or through switching valves, it can move into the volumetric flow collection, and that can be switched back and forth with the valves as shown in the figure.
So on the video on the left is going to show how to turn on the ball valve that allows the water to flow into the beaker and to turn off the valve that allows the water to flow into the reservoir. This allows the water to flow into the beaker to measure the volumetric flow rate. The video on the right here shows how to turn off the valve that lets the water flow into the beaker and to turn on the valve that allows the water to flow back into the reservoir, isolating the system so that water doesn't overflow into the lab. Finally, this is a picture of the reservoir tank on the bottom shelf of the cart. It has a drain in the middle of the reservoir that has a plug that stops the water. This can be drained directly into the floor drain located in the laboratory that it's stored and used in. This concludes the video overview of our senior design project. We want to thank you for learning more about what we've done to build a heat exchanger to allow students here at Penn State Barron to have a hands-on experience and see firsthand some of the heat exchanger theories that they're learning about in the class.